So the next one I will want to show that okay, let me show another post. This poll Saswatee Banerjee also shared. Let me show another post, and so this is a poll we have published yesterday. So let me share this also. Okay, this is the poll we published about 22 hours ago. This asks the question, what topic would you like to see in the next session of the ongoing mini workshop on computational photonics by Professor James P. Cole and Dr. Saswatee Banerjee? Number 1, computational methods. Number 2, industrial applications. Number 3, nonlinear optics. Number 4, quantum photonics. So in the poll result, only 12% have voted. We can see computational methods, it shows 8%, industrial application 33%, nonlinear optics 42%, quantum photonics 17%. So we want more of your votes, and ask your options. What do you like to have in the to see in the part 3 of the online mini workshop on computational photonics by Professor James B. Cole and Dr. Saswatee Banerjee? You can join me here inside the Zoho webinar system, and there is no registration required. It is a free registration. Like, you can click and join. You can click the QR code and join. Let me show that. Of course, I can show it. I will show a QR code here again. When that is there in the screenshots, but you can of course see it here. Let me show this image. If I can share this, okay, let me try. How does it show? The window, it is, where is this? This one. Okay. This is the thing. I can make it. Here is the QR code. Let me make it double. Okay. So you can see the QR code. You can just scan this and join the Zoho webinar system. You don't require any registration, like it is a free registration, you can click and join. So not sure if anybody would join, but I am showing you, I am giving you the option. You can join and talk to me. You can join and talk to me. The link also is there on LinkedIn post, that is there. It is there in, yes, in the post. You can see that. Just now we saw it. So you have the link and you have you can see this and you can join it. There is a link of the webinar here. You can join straight there. Let me show you once again. So this is the link. This is the link which is converted to a short URL by LinkedIn. This is actually the link to the Zoho webinar. So you can click it and join. There is no necessary of giving any of your information like name or email address. You can straightway join. Or you can scan this QR code and join from your phone. Probably Zoho ask you to use their mobile phone app, smartphone app. So you can see it in browser from desktop or laptops, and from mobile phone probably you have to use the Zoho app. So that is what. And another point we want to tell you, like just a 1 hour back or something we were discussing. So Professor Cole and Dr. Banerjee informed that in these episodes, the coming episode, we can actually consider both from the first principle using their developed coding methodologies as well as commercial packages. Means they train uh, the researchers and students how to compute it using their algorithms, their coding techniques and methodologies. It is called non-standard FDTD, and also the commercial packages available. So you can get training on both aspects. From the first principle, you can learn from Professor Cole and Dr. Banerjee how to code the propagation of waves, any electromagnetic waves. It can be microwave, it can be visible waves, it can be infrared waves, any waves. There the parameters will change for the medium the waves are propagating. So you can learn it for all your applications, starting from say optics, infrared waves, and as well as microwave wave propagation. We know that there is a good number of researchers and research students and professors. They are working on antenna design. So heavily they use microwave propagations and design their antenna systems. Uh, Most probably they use some commercial packages and plot the graph and estimate about their design parameters and show that, calculate that. Here you can learn the first principle. From first principle, how can you accurately calculate the propagation of the microwaves so that your antenna designs are more um, more into your in your hands. Like the commercial packages have limitations. However, if you are interested for commercial packages, how to use and do this microwave, do these computational methods for say Maxwell equations, you can also learn it from Professor Cole and Saswatee Banerjee. So we hope that uh, you will give your options in the LinkedIn poll, or you can write a comment directly on the last episode, which is there, the LinkedIn live and recording here on LinkedIn as well as YouTube. You can write your comments and give your options. So that also can be considered by Professor Cole and Saswatee Banerjee. So that is one point I wish to discuss and speak here and chat with you. However, nobody joined because you know that I have come to live uh, just giving you a notice half an hour back. So maybe many people are not getting intimation. But here in the LinkedIn feed or YouTube feed, if you have come across to this live, you can join me directly into the system. You don't have to register. You just click the link or scan the QR code and join. So that is the point we want to tell today. And so that we can prepare for the next episode, the part 3, which will be streamed uh, on December 20, the coming Saturday. So before that, if you give your options, Professor Cole and Saswatee Banerjee can customize their last part of the mini workshop on computational photonics, and it will be as per your requirements. So what do you say? You can write that in a comment, or you can also directly send message, LinkedIn message to me or Professor Cole or Dr. Saswatee Banerjee. You can connect with them and you can give your options. You can write to them what you want to learn in the next episode of the mini workshop on computational photonics by Professor James B. Cole and Dr. Saswatee Banerjee. So that is what I intend to share with you, and hope uh, some people will join in the next episode. We would try to announce the episode within a day. So be there and please communicate, write comments, and open up in communication. We can accept, we can consider your options and forward it to Professor Cole and Saswatee Banerjee. So the coming episode on December 20 may be customized as per your requirements and choices. So that is all. So I will end this stream and and expect that you'd write some comments and give your requisitions. This is a very interesting and useful topic, computational photonics. It spans all the electromagnetic waves. Like you can have the computation on microwaves, optics, infrared, and the propagation can be through different media. The parameters of the media would change. So learn the first principle from Professor Cole and Saswatee Banerjee. They have published a book, The Flow of Light. So let me show that book also, the book cover. Okay, let me show the book. Okay, and this is the book. So you can see the book. Uh, I hope you can see the book. So computing the flow of light, it is published from SPI Press in 2017. Uh, the subtitle is Non-Standard FDTD Methodologies for Photonics Design. So this is the content you can view, and you can also go to the website of their company, Photonic Wave Solution. That also I will show you their website. So you can visit their website and uh, let me share the website. So this is the website photonicwavesolutions.com. You have all the details. You can have all the details about their courses and what they do. So you can see their work and how do they show this. You can have self-service online courses, hands-on trainings, one-to-one tutor assistance. If you wish, you can have that. Okay. So let me show their courses page. Okay. So yes, the courses page shows this. So the courses we offer are structured in a way that will take you from the basics of electromagnetic theory that will be needed to understand and analyze the optical behavior of the nanophotonic devices through the formulations of FDTD in one dimensional and two dimensional and three dimensional, and to actual applications to real life problems. These courses will introduce you to the myriad applications of FDTD to design various nano photonic devices for novel applications. So one is Introduction to Electromagnetism. This is one course. Another one is Waves and the wave equation. Another one is electromagnetic waves and light. And another one, finite difference time domain method, FDTD. That is well known, and if you learn it, it will be an asset for you for your research career, your academic life. So you understand the Maxwell's equations and how to do an approximate calculation of the propagation of waves on the basic principle, finite difference time domain method. Finite difference time domain method, FDTD. And there is photonics and light wave technology, photonic device simulations, analytical solutions of Maxwell's equations, optimization methods in optics and photonics design, analyzing structural color and computing color coordinates, color maps for displays and visualization, and applications of optics in quantum computing. This is the final one. So it is upcoming. So if you wish, they can give some glimpse about photonic photonic what is that photonic, uh, the options are there, photonic photonic quantum, what is that, let me see, the options are there here. Sorry, I forgot, it is here. In that poll it is there, the topics, just a minute. Yes. Yeah, quantum photonics, computational methods, industrial applications, nonlinear optics, and quantum photonics. So that also you can opt for. So in the part 3 episode, they will consider that. Okay. So let me show you the options once again. So please write that in a comment and ask for what do you want in the next episode: computational methods, industrial applications, nonlinear optics, or quantum photonics. So already few people voted in this poll. So you can vote here also, and you can write that in a comment. You can connect with Professor James Cole and Dr. Saswatee Banerjee, and also write to them directly. So I will end the stream here, and since nobody is joining and asking any communication, so I have shown you, I have shared the information I have wanted to, and Professor Cole and Dr. Saswatee Banerjee wanted to convey. So please write that in a comment in this LinkedIn post, or in the LinkedIn live also, that it will be recorded, this video, and also on YouTube if somebody is watching this episode on YouTube. So I will end the stream here. Before that, let me check in the chat. No, there is no comment on YouTube. Okay. So Let me end the live stream. So, see you on the next episode, the part 3 of the online mini workshop on computational photonics by Professor James B. Cole and Dr. Saswatee Banerjee on December 20, 2025, Saturday at 9:30 p.m. Indian Standard Time. So, bye. Have a nice time. See you.